Hi and welcome. I've got today Chris Collins with me. Chris is the head of science and tech at Mudo. Mudo is a company for DNA and epigenetics testing. Hi, Chris. How are you?
Marcus, thanks for having me.
Chris, can you tell us what you do at the moment and how you spread your work?
Yep. So as you say, I'm the head of science and tech at Mudo. We started off as a DNA testing company, genetic testing company. We moved towards epigenetics early on, epigenetics being based around DNA methylation. And now we are trying to move into the big data type market with multiple data points during our collection. We're consumer and B2B. And yeah, we're slowly growing. We're in multiple countries now and in multiple languages.
Great. And I got you on because you also have a scientific interest, and you also started doing a PhD into epigenetics and aging. Possibly you continue this work with King's College in London. Maybe as a good starting point, because you probably get this question quite often, is what is the difference between genetics and epigenetics?
So they're both broad terms, and some people may use them interchangeably. So when it comes to genetics, we're normally talking about the variations in the genome itself, the fixed variations at birth, and those will affect the way certain genes may function. They are unchangeable in terms of, targeted changes. They may have mutations which can occur, but they're uncommon. But in essence, we're talking about a fixed code that you are born with and die with. Epigenetics, on the other hand, epi meaning above, is basically where there's multiple forms of epigenetics for one. So the two main ones that I looked at are methylation and histone modification. And the one we look at is methylation. This is the most abundant. And basically what occurs is that on certain points of the genome, you'll get a chemical called methyltransferase, which can attract to it, and that will affect the gene's expression. It may amplify or suppress a gene's expression based on this chemical. Unlike the genetic test, the epigenetic test can change over time based on your environment. So what you eat, how you live your life, exercises, supplements, drugs, etc., will all affect your epigenetics. And this may have a big role to play in obviously how you live and how healthy you are.
Yeah. And I think this podcast video, we want to concentrate a little bit on sports. And you wanted to tell us maybe how epigenetics can help us look better after our athletes. And
Sure.
I think you have a little presentation prepared for that.
Right. I will share my screen. So it's just a really short presentation where we can talk around it. Feel free to ask me any questions you want, Marcus, as we go. So we'll talk about injury and performance in terms of genes and how nature and nurture can come into play when it comes to sports. So we'll talk about genes first. I kind of already mentioned this when you asked me the question. So they give us our individual traits and may or may not lead to disease in the future. They can put us at higher risk of certain conditions. And in this case, they can put us at higher risk of injury occurrence, soft tissue injury, bone density issues. And obviously they can also give us our traits, our gifts. So when people say they're gifted in certain area, this may be the case of coming from their genetics. So they're born genes, they're born genotypes. And that means that they might be more prone to being a sprinter versus an endurance athlete. The ceiling is basically higher. So it's not saying you're born really fast or really strong. The ceiling, the potential to be really strong or really fast is increased for certain people based on their genotypes. And then again, we did speak about epigenetics in the beginning. So the epigenetics area is changeable, unlike genetics. And again, we look at DNA methylation for this. So if the areas are hypomethylated on a gene, that means that gene expresses more. And if there's more methylation on a gene, it means there's less gene expression. And that's a basic way of looking at how methylation works across the genome. So obviously, there are multiple risk factors when it comes to injury. And there's no point taking one of these risk factors and just focusing fully on that. You need to really take into account multiple aspects when it comes to injuries. So is it overtraining, repetitive strain? Is it from pure contact, the age of the individual, biomechanics, psychology? There's multiple areas changes which will affect somebody getting injured. And obviously genetics is the one we're going to concentrate on today, but it needs to be taken into account of all the other aspects as well. So one of the most intrinsic factors, obviously, which affects injury is going to be our genes. So how we are born. There are multiple genes which have been studied for injury, and these mainly affect things like our collagen, our strength of our muscles, and our bone density. Obviously, having less collagen, lower bone density will put you at higher risk of potential injury. Even if that injury is accidental, obviously an impact, having weaker bones, for example, will mean there's more likelihood of that bone being fractured. So our genes are like a foundational level which we should look at when we think about our individual selves, but also our players, or if we're coaching somebody. Our genetics will be that foundational level where we can get a good idea of what kind of risk factors may affect them. So I did a study in 2018, and we looked at multiple football players across from Premier League down all the way to semi-professional. And what we found was that there are certain genotypes which can be put onto a small array to be tested, and that will give you an idea of how likely it is a player to be injured and how long they may need to recover from that injury. And we found certain genotypes were linked to longer times off during matches, and they also had a higher risk of soft tissue injury, mainly affecting the knee and the ankle.
And the genotypes, can you influence them with nutrition, sleep, all these things?
Yeah, of course. So you can't affect that genotype. So we spoke in the beginning, the genotype is fixed, but you can obviously mitigate that risk. And that's the idea of doing the test in that you may understand that somebody's at a higher risk, and you may think, I'm going to train them differently with, say, different strength and conditioning methods, or I'm going to increase certain nutrients in their diet, like protein, amino acids, or whatever it might be, to help mitigate a risk factor. So you're not changing the genotype they're born with, but you are working with that genotype to help, get them to their highest potential. Because you may find that there's a player, for example, who is really talented at football, with great genetics for, say, speed or strength, but they have got risk factors of an injury. So you want that player to be able to maximize those gifts whilst mitigating the negative areas that they have in terms of injury.
Thanks.
So epigenetics and sports injury. So unlike the genetics genotypes we saw before, we can amplify and suppress certain gene expressions through our environment. So we can't change the genotype, but we can change the methylation on a gene. So if that gene isn't expressing as it should be, and that gene creates a protein which is linked to, higher bone density or higher soft tissue amplification, hypertrophy, then you want that gene to be expressing correctly. And then there might be ways in your environment or supplements that you can take which can target that area and therefore increase your body's own ability to produce the proteins that you need, or the enzymes that you might need. And that may include things like increasing protein intake. It might include things like certain amino acids can do it. There are certain acids which can improve and can basically affect our methylation. Things like phosphatidic acid can do so. And even a chocolate extract can actually affect a gene called MSTN, which can decrease your myostatin levels, for example, which can help improve hypertrophy. So there are multiple aspects which can aid in the epigenetic part, and obviously the epigenetic part can be tested. Also, with injury in epigenetics, we can look at inflammation. So we can look at the genes which might produce cytokines which are linked to inflammation. Now, that's really important, because if you analyze that over a period of time, you can then maybe see when a player is at highest risk of injury. Even though they're not injured yet, you may say their inflammation markers are high, and therefore you may want to step off the gas and change the way they train, or change their rest period or their nutrition to help prevent an injury from occurring in the future. So there are multiple aspects when it comes to epigenetics on how we can help prevent injury. So we'll move on to sports performance. Obviously, multiple factors affecting the individual's ability to perform. Their nutrition, but that's not just nutrition when they train, but nutrition from birth will be an important aspect. Their training, obviously, their motivation to actually do the training and the sport itself. Injury and illness will all have a massive role to play. But as you go more towards an elite level, genetics becomes more and more important, which we can see. If you put the 100-meter final up in the Olympics, all those guys are eating the best they can. They're all training as hard as they can. They're all motivated to be number one. They may all have different types of injuries. They may all have suffered certain illnesses. So they're all doing the best they can, but there'll be some people who are in there, obviously the people who win, who will have a slight advantage when it comes to genetics. Their ceiling for performance is slightly higher. So in terms of genetics, when it comes to like a lower level, you may say anyone who trains hard, eats well, will get to a good level. And as you go through towards the elite level, that's when genetics will play a bigger and bigger role in sports performance. So this is on myostatin. The bodybuilders will know quite a lot about myostatin. It basically helps prevent us gaining muscle mass. It helps us maintain flexibility, if you like. But obviously, if you decrease the levels of myostatin in the body, you will have increases in muscle mass because that restriction is no longer there. It has been found that multiple athletes with the MSTN, which is the gene that creates myostatin, the MSTN variations will have lower levels of myostatin and therefore more hypertrophy. And because this is from birth, they've had a long period of time for that muscle to basically improve. And if they started training early, they will have an advantage all the way from birth, thanks to this mutation. So MSTN is a big target for a lot of companies to look at, to try and gene dope, if you like, or to try and reduce myostatin, where obviously the main way to reduce myostatin is to have the genotype variants, which decrease it naturally. So we can look at a graph here for people in the normal category versus people in the AG category, which is a heterozygote mutation in MSTN. So we didn't, even though we've tested about 10,000 people, we've never found somebody with a complete mutation or GG in the genotype we look at. However, as you can see from a performance on an average, the people who are heterozygotes manage to perform more push-ups in one go and manage to perform more pull-ups as well. It is quite uncommon to see people who are heterozygotes, and it's nearly impossible to find people who are full-on the GG genotype. So polygenics. So as we spoke about before, that was just one genotype in MSTN. Now, polygenics is a way of looking at multiple genes and then adding up the power of different genotypes within those genes to give an idea of what kind of trait that might be. That trait may be being fast, being 100-meter sprint, 60-meter sprint. You can test these things, and say, is this algorithm working? Is this algorithm predicting the ability for somebody to be good at a certain sport? And that's where polygenics come in. So here's a polygenic algorithm which was created over multiple genes. And this is a push-up max in 3 minutes. As you can see, as the algorithm result goes up, so does the push-ups. Now, there is obviously variations in there, and all those variations come into account of training, motivation, etc. However, the people who are really gifted in the muscle stamina algorithm managed to produce more push-ups within 3 minutes. And the people involved in this study were all gym goers. So they all knew how to do press-ups. They were all already quite fit. They were bodybuilders, in fact. So if we go to the flip side and not talk about muscle mass, we talk about fatigue. So AMPD1 is one of the most common genetic-only conditions for metabolism. It's still uncommon, only about 3% of the population, and that's mainly in Caucasians. However, that makes it quite common for a pure genotype condition. And now, whilst most people who have it won't have any symptoms of it, it does seem to cause certain problems in people who push themselves to a very high physical limit. It means that whilst their power output isn't altered, their ability to emit that same power over a period of time is lessened. So they fatigue faster in between bouts of high intense activity. It doesn't affect everyone the same, and it might depend on what kind of variant they have in the gene, but it does seem to have some effect. Now, there has been ways of people getting around this. Certain nutritional things are recommended, such as creatine or D-ribose intake. That's to give a different type of energy source for that person. However, it is good to know if your athlete has this, because it may affect the way you train them. Because in a study that was done, I think in 2017, it showed that those with the fatigue variant, if they had more rest in between intense sessions, their actual performance went up far more than if they maintained, say, I think it was training 5 days a week versus training 3 days a week. If they trained 3 days a week, their performance went much higher, indicating that they might have had more inflammation after training and therefore more adaptation, but the adaptation took longer to occur. And if they train more, they're actually dampening the overtraining faster. So it is important to know for your athlete, but again, it's uncommon to have it, but it is quite common in terms of genetics. And again, the epigenetics, what we spoke about in injury, can affect your ability to amplify and suppress certain genes. And that again would be a method of gene doping, if you like. But it is also something you can do in your environment which can affect it. So we know that certain nutrients may affect genes which affect myostatin, or may affect your ability to hypermethylate genes, which may be negative to inflammation genes, for example. So by testing epigenetics, you get a good idea of how we can amplify and suppress talent, if you like. Whilst we're not 100% there yet, in the future, that will be the goal, is that how can we amplify this person's gifts and how can we suppress their negatives? And that's just a quick overview of genetics and epigenetics in sports and injury.
Thank you. Obviously, when you see this, you think, why is not everybody doing this?
A lot of people are doing it. A lot of football clubs do it. A lot of them aren't public about it. But I think Barcelona were testing genetics for injury years ago. I think you can still find articles on it online. So a lot of people are doing this. It's not a hidden science. There are a lot of clubs doing this, a lot of athletes doing this, and how much credence they give it depends on the club, the coach, for example. And I can imagine in certain countries it's really big, especially testing from a younger age.
Yeah. And what do you think in the future years, where should research focus? I mean, obviously it's a broad field, and there's some research already done. But if you've read into this, and you probably have a few, where should it go?
I think obviously it will go into health first, and then from health will come sports performance. For example, the genes which may affect muscle mass may help somebody with muscle dystrophy or muscle atrophy, and by altering those, that might help them live better. But those same principles could be applied to an athlete to enhance their performance, right? So it will always be health first, and then someone will take it that next step towards enhancement.
Okay. Yeah, I think that was a good overview, and I think that should be for the beginning it. And I think we're going to get you back when we've got a bit more data, and maybe we speak next time about aging and what you can do, what epigenetics can do for you about that.
Sure. Yep.
Thank
Sounds
you, Chris.
Good. Thank you.